evening, everyone. We are in the week 12 problem solving session of the NPTEL course, Basic Electrical Circuits. And week 12 is about steady state response using equivalent elements. Let me share my screen. Can you see my screen?
Yes.
So previously we have studied about transient response as well as steady state response as a function of time and how do we calculate it. So we have seen that we get the differential equation, and from the differential equation first we'll find the roots and then we'll get the transient response, and then for forced response we have considered it as a scaled version of the input, and then we have back substituted it to find the coefficients. So now what we are going to discuss in week 1 is, say our aim is to find the steady state response, not transient response, because in most of our day-to-day applications we'll only be needing the steady state response, because transient response anyway is going to die out when it reaches steady state. So at steady state, what is the not inductor, what is the current, what is the voltage? So if my aim is to find the steady state response, then is there any shortcut way or is there any simplified method which will save me time and I can get immediate or quickly the expression for the current as well as voltage? So today we are going to only discuss about the steady state response. So we know that steady state response, we consider it's like a forced response, right? Because we have discussed about multiple names, and we have seen that forced response is the steady state response and natural response is the transient response. So whenever we say steady state response, it is because of the some forcing function, input voltage, or it could be current. So because of some excitation, whether it could be voltage or current, there is some response in the circuit. It could be again voltage or current in any of the branch. So for that given input, what is the output voltage or current during the steady state? Say we have some circuit. We have some network, and say the input voltage is something like Vp cos omega t plus phi. So this is Vp cos omega t plus phi. So now let us see Vp cos omega t plus phi is nothing but real part of Vp into e to the power j of omega t plus phi. Agree? Because e to the power j x is j theta is cos theta plus j sin theta. So we have written it something like this. Agree? Yes. Okay. So now we are going to do j omega t plus phi. So now I can segregate it into two terms. Say I'll write it as real part of Vp into e to the power j phi into real part of e to the power j omega t. Agree? Or maybe I can keep one real term. So let us just write it something like this. Real part into e to the power j omega t. Is this fine? So now let us, this is a some imaginary number, right? Some complex number, because it is Vp into e to the power j5, but it is not a function of time. So I'm calling it as some Vp phasor. When I'm saying Vp phasor, it means it's a complex term. So now this term we have Vp cos omega t plus 5 is equal to real part of Vp phasor into e to the power j omega t. So is this clear? We have written the input voltage in some different form where we have written everything in terms of phasor. Is that clear? Hello. Okay. Yes, sir. Yeah. So now we have seen that if input is say some cos function or some sine function, any voltage or any current will be its scaled version, and there will be some phase difference phi. So now let us say in this network there are three voltages. So let us consider there are three voltages. Voltages in the sense some terminal voltages, not voltage source. Three voltages, and they are, let us considering VA, VB, VC in the given network. Okay. So now what happens? So now what happens is I can uh, write something like this. I can write VA is some real part of VA bar phasor into e to the power j omega t. Similarly, VB is equal to real part of some phasor VB bar into e to the power j omega, and VC is equals to real part of VC bar into e to the power j omega t. If you see, only the phasor will change. E to the power j omega t remains constant because, as I have told, if the input is having cos omega t, all the forced response, maybe current or voltages, will also have the omega t term. Maybe the phase will change, but omega t will remain the same. So here Vp bar is Vp into e to the power j phi. Here Va bar will be Va into e to the power j phi 1. So maybe we can also write it. So Va bar will be some voltage, say VA1, VA, or maybe I'll name it V1, e to the power j phi 1. Because we don't know the phase, we don't know the magnitude, because that's what we have studied, right? It will be a scaled version of the input function. So we are considering it as V1 cos of omega t plus phi 1, and we are writing in a different way now. So now VB bar is equals to some voltage V2 into e to the power j phi. Now VC bar is equals to V3 into e to the power j phi 3. So keep in mind that these are all post response, not the transient response. So at steady state, we are using a different representation to write the voltages. It could be for current as well, but here we are writing for voltages. So now you may ask, like, what is the advantage of writing this? Because it is the same way of writing in this way. We are writing in this way, which may look complicated at this point of time, but what is the advantage of that? Okay, let us get into it. So now, say I have, so first we'll be discussing about resistor, then inductor, then capacitor. Okay. So resistor. So we have a resistor R, IR of T, and say the voltage is VR of T. So first we'll write according to the phasor that we have. So uh, IR of T is equal to real part of, say, some IR phasor into e to the power j omega t, and VR of T will also be something like that, right? So real part of VR phasor into e to the power j omega. Agree? Yes. So now what we are doing is, we know that VR of T is equals to R into IR of T. This is the equation, voltage current relationship of a resistor. So if you substitute it, what you will be getting is you will be getting something like this. You will be getting VR bar, VR bar phasor is equals to R into IR bar phasor. So we are talking about only the phasor terms. Because if I substituted that real part, so it will get cancelled and we'll get VR bar equal to R into IR bar. So is this clear? I have skipped one step, but is this clear? I have skipped one part. If you substitute IR of t as well as VR of t in this, then you will get something like this. Agree? Or should I explain how I am getting VR bar equal to R into IR bar? Explain, sir. Okay. So, so what I'm going to do is I'm substituting everything in this. So VR of t is real part of VR bar into e to the power j omega t is equals to R into real part of IR bar into e to the power j omega. So now what I'm going to do is I will take R inside. So R is a real number, right? It is not imaginary. So I can directly take it inside. So I'll have real part of VR bar into e to the power j omega t is equals to real part of R into VR bar e to the power j omega t. So if I now compare on both the sides, this will get cancelled with this. So I am left with real part of VR bar is equals to R into VR bar. So basically real part are equal. So I can directly write that VR bar is equals to R into uh, VR bar. Sorry, IR bar. I have made a mistake here. This is IR bar. Agree? Now is this clear? So basically what we'll do is in this entire finding the forced response, we'll write everything in terms of phasor. So we'll write VR bar, IR bar, VC bar, IC bar, everything. We'll simplify the circuit and we'll solve the circuit in phasor. And when writing the final expression, we'll put the real part of phasor into e to the power j omega t. So now for resistor, it is same. VR bar is R into IR bar. Now let us see for capacitor how it is coming. So let us consider the current as IC of t and the voltage is VC of t and the capacitance value is C. So first we are writing the generalized expression. IC of t is equal to real part of IC bar into e to the power j omega t and VC of t is equals to real part of VC bar into e to the power j omega t. Okay, now I know what is the capacitance voltage current relationship. Anyone?
IC is equal to C dVC by dt.
Sorry.
IC is equal to C into dVC by dt.
Yes. So IC is equals to C into dVC by dt. So let us substitute it. So IC is nothing but real part of IC bar into e to the power j omega t and C into dVC by dt is uh, real part of VC bar into j omega into e to the power j omega t. Agree? What I am writing. So first let us take this capacitor inside and again e to the power j omega t, e to the power j omega t gets cancelled. So now if I write the voltage current relationship, I'll be getting something like this. VC phasor is equal to IC phasor by j omega. Clear? Any queries? I have taken C inside and then I have simplified. Yes. So basically what we are trying to do is, if you see, we have converted everything into phasor, which is an imaginary quantity. So that's why we are getting in terms of J. So now what happens is, here, if you see, we are getting the voltage current relationships directly without any time dependent term. Because whenever we are solving for a capacitor, we have I equal to C dVc by dt. We have one differential equation, right? And trying to solve this means we have to solve the differential equation. But if it is a second order, we'll have a second order differential equation. But now here what we are doing is, because we are converting everything into phasor, we are directly getting some VC bar is equals to some complex number into IC bar. So it is just similar to a resistor, but here we have R, here we have 1 by j omega c. So now what happens is, now I can solve everything in VC bar, I mean phasors, and then we can directly solve. So that we'll understand once we go to the problem solving session. So true if the input is cosine. What if we have other input like sine or DC? Yes, very good question. So I'll come back to it once I discuss the inductor part. So if it is a DC, things are very simple, because if it's a DC, we know that inductor will be saturated at the steady state. So inductor acts like short, capacitor acts like open source. So for DC it is okay. But what if it is sine? So I'll come to that part. But let me first complete the inductor part. So now we have inductor. We have well L. This is IL of T. This is plus minus VL of T. So now we have IL of T. Generalized term is real part of some IL bar into e to the power j omega t, and VL of t is the real part of VL bar into e to the power j omega t. What is the uh, inductor current inductor voltage relationship?
VL is equal to L into DIL by dt.
Yes. So VL of t is equal to L into DIL of t by dt. So let us substitute everything. Then we have real part of VL bar into e to the power j omega t is equal to L into real part of IL bar into e to the power j omega t into j omega. So now, if you see it is for j omega t cancel, and if you take it inside, you'll get the expression something like this. VL bar is equal to IL bar into j omega. So basically, now we are getting the current voltage relationship of resistor, capacitor, as well as inductor. So now, before we go into further details, I would like to emphasize on something called impedance. Impedance is like a complex quantity of the resistance. So it is defined as something like this. Z is the impedance complex number is equal to R plus J into X. So this is that is called as impedance. And resistor is R is resistance, and X is called as reactance. So this is the like complex quantity of resistance. Resistance is real, but if you see j omega L, it is complex. 1 by j omega c, it is also complex. So we have real plus some imaginary number. Overall is called as impedance. Real part is called as resistance. Imaginary part is called reactance. So I can also now define the impedance of resistor, inductor, and capacitor. So now let us say that first let us write as V phasor is equal to some impedance Z into I phasor. Okay. So now this is some generalized equation. So what is the value of Z? So we are bothered about Z. What is the value of Z per resistor, per capacitor, per inductor? So we are finding the value of Z here. What is the value of Z? R, 1 by j omega c. Yeah, Roshan, you are right. And for inductor, j omega. Yes, very good. So for resistor, it is R. For capacitor, it is 1 by j omega c. For inductor, it is j omega L. How we are getting this? From our previous discussion, VR bar equal to R into IR bar. So if there is any voltage and current, for resistor, it is voltage equal to resistor into current. Here, voltage is equals to 1 by j omega c into current. So here the impedance Z is 1 by j omega c. Here it is j omega L. Baby Priya, is this clear? How we are getting these expressions?
Yes, 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 sir.
Yeah. So now what happens is, say for example, we have, let us consider one example. So I'm just giving you an idea of how we can solve the problems. So we have one series RLC circuit. Yes, minus. So the value is R, L, C, and this is a 2 cos 10 t. So now what we are going to do is, first we'll be converting this circuit into the phasor one. How we are going to convert? We have resistor, we have inductor, we have capacitor, we have voltage source. So now what we are doing is, so this I am considering it as 2 cos 10t, right? First, everything we'll write in terms of real. So basically, how we are going to solve is, say, for any current or voltage expression, it is real of IC bar into e to the power j omega t. So e to the power j omega t is there in every term. So we need not explicitly write. We'll solve everything in terms of phasor. So once you got the phasor, for calculating the time domain expression, you will write real of that phasor into e to the power j omega t. So how is this be written? So 2 cos 10t is nothing but 2 into real part, or maybe I should write real part of 2 into e to the power j 10t, and there is no phase. So 2 is the phasor, right? So here we have 2, and this is resistor R. This is written as j omega L. This is written as 1 by j omega C. And say the current is I phasor I. So now everything is written in terms of phasor. We are not writing everything in terms of like a real part of phasor into e to the power j omega t, because that will make things complicated. So we are writing everything in phasor. So now if I ask you to calculate something in terms of time domain, then we'll write at the end real part of phasor into e to the power j omega t. What I mean to say is, yes, 2 angle 0 degree, you are absolutely right. So uh, now say if I have to calculate I phasor, I'll be getting 2 by R plus j omega L plus 1 by j omega c. So now if resistor is given, inductor is given, capacitance is given, then you can calculate this value. Say for example, we are getting this something like 1 milliampere, say 1 milliampere into e to the power, say some j 30 degrees. So this is for example, I am not giving, say I am saying I have obtained this value. So now what happens is, so I have calculated in terms of phasor. So now uh, you might be asked what is the value of I of t. So I can write as I of t is real part of I phasor into e to the power j omega. So it is real part of I phasor is 1 milliampere into e to the power j 30 degrees into e to the power j omega. So from this, we'll be getting something like this. I of t is equal to 1 into, so cos omega t plus 30 degrees milliampere. Yes, 1 milliampere cos 10t plus 30 degrees. So omega is 10 here. Yeah. So we can directly write as cos 10t plus 30 degrees. So if you see, we have not solved any differential equation. We are directly getting the expression for the steady state. So these are the steady state response. So first we are converting everything in terms of phasor. Once we are converting everything into phasor, then we are solving everything in terms of phasor. So once we got the value, say if they are asking VC is nothing but I bar into 1 by j omega c. So everything we'll calculate in terms of phasor. Once we are done calculating in phasor, then if they are asking some time domain expression, then we'll use this generalized expression that we have discussed earlier. And from there, we'll be getting this time domain expression. So is this clear? How we are solving for these circuits?
Sorry.
Yes, clear. So now, as someone has mentioned in the chat box, we have polar form and rectangular form. So what I mean to say is, here I have impedance Z as R plus JX. So now if I ask what is the magnitude of Z, what will be the magnitude of Z? Hello. What will be the magnitude of Z? So Z is a complex number, R plus JX. So what will be the magnitude of Z? R square plus X square square root. Yes, you are right. So it is square root of R square plus X square. So if I also ask you what is the angle of Z? Angle of Z. How to calculate the angle of Z? Anyone? Tan inverse X by R.
Tan
Yes.
inverse of x by r.
Yes, yes. Tan inverse of X by R. So now we got the magnitude of Z as well as we got the angle of Z. So now Z can be written in two ways. So Z can be written as R plus Jx, which is the rectangular form, and Z can also be written as in polar form, which is something like R angle theta. So here it is square root of R square plus X square angle tan inverse X by R. So this is more widely used R angle theta. And if you have calculators, you can also enter the numbers in R angle theta and you can solve it in a simpler way. So now we'll get back to the question someone has asked. So say my input is 2, or say let it be more generic, VP cos omega t plus phi. So VP cos omega t plus phi, I am writing it as real part of VP phasor into e to the power j omega t. Now here VP phasor is equals to what? VP phasor is VP into e to the power j phi, right? VP into e to the power j phi. Or I can write as VP phasor is equal to VP angle phi. Agree? So basically, VP phasor is VP into e to the power j phi. E to the power j phi is what? It is angle phi. Got it? Or if I have to write it, it is nothing but Vp cos phi plus j Vp sin phi, which means the magnitude is Vp and phase is phi. So Vp phasor is nothing but Vp angle phi. Is this clear or do you have any doubts? Clear or any doubt? Hello. Clear. Okay. So now say the input is Vp sin omega t plus phi. So now what happens? So now how will I be writing? Any idea what how we'll be writing?
This imaginary part of
We cannot write that because if you write imaginary part, then there will be one j also, right? J term. So imaginary part of
okay, okay.
2 plus 3j is
E power
j3.
minus j omega t maybe
E to the power.
minus j omega t.
Uh, but if it is e to the power minus j omega, we'll get cos of minus j omega, right? Like real part of Vp bar into e to the power minus j omega t is Vp cos of minus omega t plus 5, right?
Or
But I
omega
need
t
in terms
plus
of
90 degrees, something like that.
yes, yes, yes. Yeah, you're right. So we have to write in terms of cos. So now how will I be writing? I know that cos 90 minus theta is sin theta. So I'll write Vb into cos 90 degrees minus omega t minus 5 because cos 90 minus theta is equal to cos theta. Also, cos of minus theta equal to cos theta. So I will write this as Vp cos omega t plus 5 minus 90 degrees because I need plus omega t because every term has cos plus omega t. So that's why I want to write everything in terms of cos plus omega t. So now this is nothing but real part of Vp phasor into e to the power j omega t. So now here, what is Vp phasor here? Like in this equation, how we have written, what is Vp phasor for this expression?
Vp e power j 5 minus 90.
Yes. Vp e to the power j 5 minus 90 degrees. You are correct. So now, if I have to write it in polar form, I will write it as Vp phasor is equals to Vp angle 5 minus 90 degrees. So if it is sine, I will get minus 90 degrees term. Else, if it is cos, it is very straightforward. So now we are going to use all these things to solve the problems for today's session. But let me just summarize what we have discussed in uh, today's discussion. So we have discussed that if we are finding the steady state response or forced response for a given network, we need not solve the differential equation, but instead we can use some way where we can write everything in terms of phasors and then we can solve those phasors and finally we can write the time domain expression. So we know that for forced response, if the input is some cosine or sine function, then any voltage or current is the scaled version of that cosine or sine function with some phase delay phi. So now we are writing this Vp cos omega t plus phi in terms of phasors like a real part of Vp bar into e to the power j omega t. And we can also write any voltages or any current value in the same way. Now we can deal the circuit in terms of phasors, but before dealing, we have to see how the resistor, capacitor, and inductor impedance looks like in terms of phasor. So for resistor, it is simple and straightforward. VR bar equal to R into IR bar. For capacitor, you will get VC bar equal to 1 by j omega c into IC bar. For inductor, you will get VL bar equal to j omega L into IL bar. So impedance is defined as R plus jx, where R is resistance and X is reactance. So the impedance of resistor, capacitor, and inductor in this phasor notation will be R, 1 by j omega c and j omega L. So for any given circuit, first we'll convert everything in terms of phasor. We'll solve the phasor. Then we'll write everything back in the time domain expression using this real part of phasor into e to the power j omega t equation. And also complex numbers can also be written in terms of polar form, which is r angle theta, where r is the magnitude and theta is the phase. So if the input is Vp cos omega t plus phi, then our phasor is Vp angle phi. If the input is Vp sin omega t plus phi, then our phasor is Vp phi minus 90 degrees. So yeah, that is all about today's discussion. Before we go into problem solving session, you are having a doubt, right? Can you share can you send the screenshot in the chat, Roshan?
Shall I attach the file in chat?
Uh, yes, actually, Roshan was also having some doubt. If you can send the screenshot, that would be good, like how he is sending. I'll take a snip of that and I'll show. So here, if you see, they're saying why does the phasor response and time response of the voltage across capacitor for the below circuit different? Natural response does not diode, and the voltage across the capacitor, what will be the expression for the current across the capacitor? Yeah, so this is one of the like condition where you will be getting this additional term because the natural response does not diode. So this sir has explained in the in his lectures, and that's why I have not mentioned it again. Here, the natural response does not diode. Why? Because if you see the resistor, like the time constant here, what is the resistor across these two terminals? It is infinite. R is infinite, which means time constant RC is also infinite, which means if there is any natural response, then it will not diode. It will remain the same. So that's why in this circuit, if you calculate the time response and if you calculate the phasor response, you will not get the same because there is one natural response term which will not diode because there is no resistance. Had there been a resistant term, that natural response will die down. First of all, there is less than a minute, so if this meeting can kindly join me. So the voltage across the capacitor, what will be the representation for the current across the capacitor? So the voltage across the capacitor, what will be the expression for current across the capacitor? So I'm not sure whether they're asking voltage or whether they're asking current. So I bar, if this meeting ends, kindly join that. So I bar is 1 milliampere angle minus 90 degrees. Agree?
Sir, this question they have not mentioned that whether it is linked with the question number 8 or not. The
Exactly.
question
That's what I'm also not sure because they have given the value of C, but here they have not given the value of C. But I'm not sure whether it is linked or not. If you see, the question is also not proper because they are saying the voltage across the capacitor, what will be the expression for current across the capacitor? I'm not sure, but I'm just I want to discuss
sir,
what I want. Yeah.
can you communicate this to the other members because I have written it in the group also, but I have not got any response. So
Okay.
if this may be excluded of assignment, this is one question, and another question. In the previous week also, I have solved it to so many times, but I get the different answer, and I have checked it also. But the marked answer was wrong. So I emailed it there also, but there was no
No
response. I
response.
will share that one also.
Yes. Better, I
Yes,
would
sir.
suggest you to send me a mail with this screenshot so that I can forward that mail to the corresponding TS.
Oh, sir, I have written these things in the group that is there in
Forums.
the Google
Okay.
group.
Okay.
Forum.
Okay. Okay. I'll check there.
Yes.
Yeah. So because it is a capacitor, we know that V bar is equals to 1 by j omega c into I bar. So they are asking voltage in terms of current or current in terms of voltage. They they have written current in terms of voltage, but current is already given. I'm not sure what exactly they want to get here because this question seems like a little bit ambiguous because they're writing current in terms of voltage, but then they have written cos omega t minus 90 degrees. Then it should be sine. Okay. So let us write V bar is equals to 1 by j omega c is what? Omega c angle 90 degrees into I bar. So even if uh, like even if let us assume that they are asking V1 only, then what can we do? So I bar is equals to omega c angle 90 degrees into V bar. So omega is how much? 1000 c, but they are asking in terms of V1. Okay. But V is also unknown. I. But what is V1 here? They have not given anything. I'm not sure what exactly they are asking because V1 is not defined. And I'm not sure whether I or current, what is, we need input voltage info, without we cannot solve. No, actually, I was thinking they were asking voltage. So let us see that if they are asking the voltage, then how to solve? Because they cannot ask current because current expression is already given. It is 1 milliampere into sine 1000 t. But here, I don't know, like what exactly they are trying to ask. So let it be. Say if they are asking V bar, then we'll see how to solve. V bar is 1 by omega c angle 90 degrees into I phasor. I phasor is 1 milliampere angle minus 90 degrees. So V bar is equals to what? Omega c is how much? Omega c is 1000 into 1 micro, which is 1 milli. And this is also 1 milli. So this will get cancelled. So V bar will get 1 angle minus 180 degrees. So now V of t is equal to real part of V phasor, which is 1 into e to the power j omega minus 180 degrees into e to the power j omega t. So now this will be V of t is equal to cos omega t minus 180 degrees. You'll get something like this. But I'm not sure what exactly they're asking. If they have asked V of t, this is the way to calculate. At least is this clear?
Yes, sir, clear. But
Okay.
sir, try to exclude this from evaluation. So it will be
Yes,
helpful.
yes.
Otherwise, the marks are becoming low.
Okay, okay. Okay, I'll check. I'll check with the, yeah. And the baby Priya has asked one question. For the given below, find out the H parameters, calculate the value of. Yeah, so baby Priya, what is your query in this?
We have to solve all the H parameters.
Yes, you have to solve all the H parameters.
Is there any shortcut for getting?
No, no, no. These questions we have already discussed. Like there is no shortcut as such. You have to calculate the H parameters because how can we calculate the parameters? Using the definition, how they are defined. So using that definition only, we have to short circuit or open circuit accordingly, and then calculate the corresponding voltages and currents, and then from there you have to calculate the H parameters. Yeah, I know that they are lengthy, but it is the way
Yeah, that is
we have to
lengthy.
solve.
That's why I asked if there is any
Yes, yes.
shortcut.
No, that is the only way, because we have also solved this in during like when I was conducting the session, and I have
Oh,
solved the like the with the only way by solving all the parameters. So like if you see Z parameters or Y parameters, for easiest example, I am saying Z parameter is voltage by current. So
yes,
when the other current is zero, so we'll
yes.
open terminal one thing, and then we'll find the voltage and current. So actually, what I mean to say is, maybe I'll write. So say for Z parameters, we have something like this. V1, V2, V1, we have Z11, Z12, Z21, Z2 into I1, I2. So now if you see, whenever you are making I2 is equals to 0, then you can calculate Z11 and Z12. Whenever you are making I1 equals to 0, you can calculate Z21 and Z22. So you have to first make I1 equals to 0, and then you have to find the voltages V1 as well as V2. Then you will get two parameters. And then after that, you have to make I1 equals to 0, and then again find V1 and V2, and then you will get Z21 and Z22. So at a stretch, you will get two parameters, and from there, you can get the like two parameters at a time. So you have to solve the circuit twice by making this as open circuit and that as open circuit, and accordingly you will be getting. Is that clear?
Okay. Yes, it is clear. I'll try it, and if I have any doubt, will you
Yes.
be coming for next classes, sir?
Yes, yes. Tomorrow I have a 1 hour session where first I'm thinking that I'll try to summarize what I have discussed in these entire 12 weeks. So if you have any doubts, you can also ask. It will be only 1 hour session. So we'll see if there are doubts, then I'll not summarize, I'll solve the doubts. But if you have any doubts, then we can discuss. If you don't have any doubts, I'll just summarize what we have discussed. I'll just go through all my
Okay, I'll
notes.
try this problem, and if I have any doubt, I'll ask tomorrow.
Okay. So Roshan has asked one question. Okay. So Roshan has asked this question. Let it be doubt 3. So can you solve another example with a simple RL equation? R is 20 ohm, voltage input is Vm angle 0, supply frequency is 50 Hertz, and VL leads the input voltage by 25 degrees. What is the value of inductor? Unknown. How to find the value of L? Okay. So let us see. We have one resistor, and we have one inductor, and we have one voltage source. So the resistor value is R, and they have given 20 ohm, and the inductor is L, but it should be j omega L, because everything is converted into phasor. Now this is VL is Vm angle 0 degrees. So they are saying the VL leads input voltage by 25 degrees, which means the voltage here plus minus, say the phasor voltage is VL bar. VL bar will be something like this. VL bar will be VL angle 25 degrees, because it should lead the supply voltage, right? So we got the phase value of the inductor voltage phasor. So they have given one value, and there is only one unknown in the this circuit. So one equation, one unknown we have to solve. So first of all, what will be the VL phasor? VL phasor is nothing but impedance of the inductor by the overall impedance R plus J omega L into supply voltage, which is VM angle 0
Sir,
degrees.
is it VL angle 25 degree or VM angle 25 degree, sir?
Because they have said only it leads the input voltage by 25 degrees, and we cannot be sure that whether it is of the same magnitude or not. So we cannot define whether the magnitude is same or not, because they have only mentioned that
Okay.
VL leads the input voltage by 25 degrees. They have not said anything
Okay.
that it has the same magnitude or not.
Okay.
So frequency is 50 hertz. That implies omega is 2 pi into 50, which is 100 pi. So now I know that the phase of VL bar is 25 degrees. So what is the phase of this? The phase of this is 0 degrees. And the phase of this is how much? J omega. What is the phase of J omega? Ninety degrees, yes. So this is 90 degrees. And what is the phase of this one?
Tan inverse of omega L by R.
Yes. Tan inverse of omega L by R. So what is the overall phase?
90 minus tan inverse of omega L by R.
Just a minute. My laptop is out of charge. Yeah. So 90 degrees minus tan inverse of omega L, which is 100 pi into L by, sorry, 100 pi into inductance by resistor is 20. So this you have to solve and you have to get the value of inductance. I'll not be solving, you can try and you can check. Okay. So someone has posted another question. Let us see. Okay. Let me take a slip out of this and then let us discuss. This will be our doubt 4. In the figure below, determine the voltage V1 at t equal to 5 milliseconds. The capacitor voltage and inductor are 0 at t equals to 0. Consider L and okay. So they're asking what is the value of V1. Okay. So what is VL? VL is equal to L into DIL by dt. And IC is equal to C into dVC by dt. So I will find VL, which is L into DIL by dt. And then I will find VC, which is 1 by C integration IC into dt. So what is VL at t equal to 5 millisecond? At this point, I have to find the slope and I have to multiply by the inductance. Inductance is 0.4. And what is the slope at that? Slope is 5 by 1 minus 5, right? Agree? Slope at that point. Agree?
Yes, yes.
Yeah. So now for calculating the VC, I have to do 1 by C into the area until 5. So if you see,
My doubt is whether we have to calculate the full area till 5.
yes, yes.
So we will have one rectangular area alone. All the others will get cancelled.
Yes. So these two are same. And similarly, these two are same. So we have only rectangular area, which is 5. So 1 by C into 5. C is how much? 2 microfarad.
Yes.
So area is what? 5 into
1.
5 milli into time is also 1 milli. So C is 2 micro. So we have VC is 2.5 volt. So therefore overall V1, if we calculate, V1 equal
Point.
to VL plus VC. That implies V1 equal to 0.5. Is it clear?
Yes, it's clear. Thank you.
Okay. So now let us solve few problems from assignment 1. These are also very simple and straightforward, but we'll try to understand how to solve this. So they're asking value of VP and then phi. So first everything we will convert into phasor and then we'll solve it in terms of phasor. So this is our today's problem solving session. This is our first problem. Okay, so Vs is equals to cos 2 root 2 into 10 to the power 6 into t. So what is omega in this problem?
10 power 6.
Hello.
10 power 6. 10 power 6.
Into 2 root 2 is also there, right?
Yeah, 2 root 2, 10 power 6.
Yeah. 2 root 2 into 10 to the power 6. And what is Vs phasor?
6 e power
6 e power.
j.
Sorry,
Just 6.
just 6, right? If you see here, I have discussed cos omega t plus phi is 6 angle 5. Here phi is 0, so it is 6 angle 0. Or I can write simply 6. So 6 angle 0 degrees. So Vs is there. So what they're asking voltage across the capacitor. So first let us redraw the circuit in terms of the modified impedance and phasor. So this is 6 angle 0. Resistor is 1 kilo ohm. And what is capacitance value?
1
One-
nanofarad.
1 by j omega c, right?
Right.
Can you tell me what will be the value of 1 by j omega c? Or for the time being, let it be 1 by j omega c. We'll substitute at the end and then we'll see. 1 by j omega c. So now they're asking V naught phasor, right? So V naught phasor will be what? Expression. So this is V naught.
V naught phasor is IC phasor into X. I phasor into X.
Okay, and what is I phasor?
By 1 plus 1 by 2.
Yes. So I can consider this as a resistor divider. So the voltage across this impedance is 1 by j omega c by 1 kilo, or say maybe I'll write everything in terms of R 1 plus 1 j omega c. So what you said is similar to this. You have said I into 1 by j omega c, and basically
Yes.
this term is I. So which is also the same. Now if I simplify this, I'll be getting V naught phasor equal to 1 by 1 plus j omega RC into 6 angle 0 degrees. Can you calculate what is the value of j omega RC and tell me what is the value of j omega RC or omega RC? Can you tell? Omega is how much? 2 root 2 into 10 to the power 6. R is 1 kilo ohm. C is 1 nanofarad. I have calculated, but I want to see whether we are getting the same values or not.
This is just 2 root 2.
Sorry.
2 root 2.
2 root 2. So it will be how much? 1.414 into 2. 2.828. Yeah. Very good.
Yes.
So V0 phasor is 1 by 1 plus J 2.828 into 6 angle 0 degrees. So now, can you calculate and tell me what is the magnitude of V0 and what is the phase of V0? So what is the magnitude of V0? It is 6 by square root of 1 square plus 2.828 square. And phase is what? 0 minus tan inverse 2.828.
Magnitude of V0 is 2,
Okay, V0 is how much?
2 volts.
2 volt. 2.
2.0002.
Okay, okay. 2. And then angle?
70.53.
No, minus.
Minus 70.53.
Minus 70.5. Roshan, are you getting the same value or anything different? Okay. So now I have got V0. So if I want to calculate V0 of T, what will be V0 of T? Doing, sir. Okay. You just check and let me know whether you are getting the same. So V0 phasor is this, and omega is 2 root 2 10 to the power T. So what will be the V0 of T in terms of, say, cos? Directly give me the expression.
2 cos omega t minus 70.5.
2 cos omega is 2 root 2 into 10 to the power 6. T minus 70.5 degree. So this is the overall expression. It is very simple. We have not solved the differential equation. We have not derived the differential equation. We have just done everything in terms of phases, and it is pretty much straightforward. Yes, sir, correct. Okay. Now, if you see what is VP, VP is 2. And what is phi? Phi is minus 70.5. Let us go back and check. So VP is 2 in the range of 1.9 and 2.1. And this is minus 70.5. So it is also correct. So is this question clear or do you have any doubts?
Clear.
Clear. So now let us solve another question. So now this is if you see, now you will understand the advantage of this method, because now it is a second order differential equation circuit. So let us see what we are getting. So this will be our second problem for today. Okay, what is omega in this circuit?
10 to the power 6.
10 to the power 6. Yeah. Now, what is Vs phasor?
5
5 what?
angle 0.
0.
Are you sure? Is it sine or cosine?
Yes, cosine means 0. Sine means is it 90 degrees or plus 90
Okay.
or minus 90?
Okay, okay. We'll go back and see. So now you tell me. So in the question they have given Vp sine omega t. So what will be the phasor?
Sir, minus 90 degree.
Yes, minus 90, not plus 90. So plus 90 leads to some other value. So minus 90 is the correct answer. So Vs angle minus 90 degrees. And these are very important, because if you make a mistake at Vs, phasor only, then your V1 phasor will also be wrong. So we have to be very, very careful. And then let me write the values. This is R, this is j omega L, this is 1 by j omega C. So now what will be the value of V1? Like V1 phasor, what is the value of V1 phasor? Anyone? Sir, please explain this plus 90 or minus 90. Okay. So if you see this term, sine omega t plus phi, we have written it as cos 90 minus theta, and cos theta is cos minus theta. So omega t plus phi minus 90 degrees. So that's why we are getting minus 90 degrees. If it is plus 90 degrees, what will happen? It will be cos omega t plus phi plus 90 degrees, which will make it minus sine omega t plus phi. But the input is sine omega t plus phi, which is cos 90 minus theta. If it is cos 90 plus omega t plus phi, then you will get VP angle phi plus 90 degrees. But if it is cos 90 plus omega t plus phi, then it will be minus of sine omega t plus phi, which is not correct. So that's why we are getting minus 90. Okay. So what will be the expression for here V1 phasor?
We can apply voltage division rule again.
Yes, yes, yeah, same. So now if I write the
Here
expression,
into j omega c plus j omega L plus 1 by j omega c divided by R plus j omega L plus 1 by j omega c into Vs. Phasor.
yes. So now if I simplify this, I will get 1 minus omega square LC by 1 minus omega square LC plus j omega RC into Vs is 5 angle minus 90 degrees. Okay, so now tell me the value of 1 minus omega square LC.
Please show the circuit. What is the value of L and C?
Okay, okay. So L is 1 micro, C is 1 nano, omega is 10 to the power 6. So 10 to the power 12 into 10 to the power minus 15, 10 to the power minus 3, I guess. 1 minus 10 to the power minus 3.
1 minus 10 power minus 2. Point 99.
0.999, right? How much? 0.999.
0.999.
Just check and let me know.
Yes, 0.999.
0.999. So this is 0.999. So the denominator also that is 0.999. Let me know the value of this. We have 0.999, right? 0.999 plus j omega RC. R is 1 kilo.
1.
1.
J omega RC is 1.
Okay. So it is plus j into 5 angle minus 90 degrees. So now can you calculate this and tell me in terms of R angle theta, what is V1 phasor? In terms of R angle theta. I hope everyone is doing and understood how to do.
Yes, yes, please.
Yeah. So you have to first find the magnitude and then find the phase.
3.5.
3.5.
3.5 and angle is minus 135.
Okay. So now what will be V1 of T?
V1 of T will be 3.5 cos omega T minus 135.
Omega is 24.6. Minus 132. So this is our final V1 of the expression. Let us see. So VP is 3.5, phi is minus 132. So VP is 3.5, which is matching, and 5 is minus 135, and it is also matching. So is this question clear to everyone? How we have solved? We have converted everything into the phasor values, which is R for resistor, j omega for inductor, 1 by j omega c for capacitor. And then we have calculated the expression for V1 phasor. Then we have substituted all the values to get V1 phasor in terms of R angle theta. Once we know R angle theta, we can directly convert it into the cosine or sine. So is this clear, everyone? Roshan and Sauna. Any queries until this point?
No.
Okay. So now let us solve another question.
Clear?
Sorry. Okay, clear.
Yes,
So
sir,
now
clear.
this is somewhat tricky, but still okay. How to calculate, how to proceed with this problem. So this is our problem 3. Problem 3. So how to proceed or how to solve this problem? Someone has mentioned, sir, convert it into voltage source. Yes, sir, clear. Yeah. Okay, we can convert it into voltage source, but after that, what we'll do, there will be 2 voltage source. What can we do with it?
You have to add it algebraically.
Yes, we have to add it and then we have to solve for the V1. Very good. So if we convert it into voltage source, here we'll have plus and here we'll have minus, right? Because the current is flowing in this way, right? Agree?
Yes, yes.
Yeah. So now, let me redraw this. Maybe I'll draw it here. So I have inductor, I have resistor, I have capacitor. I have one voltage source with my plus here, minus here, and another voltage source with plus here, minus here. Okay. So let us write the values. So this is j omega, this is R, this is 1 by j omega. And this is, so now let us write in terms of phasor. So this is say Vs. So what will be the Vs phasor? Vs phasor?
3 angle 0.
3 angle 0. Okay. And what will be the other voltage phasor?
4 angle minus 90.
4 angle
Minus 90.
minus 9. Oh. So now how will we proceed? So
You have to convert the 2 voltage into a single voltage.
Yes, yes. So we will convert both the voltages into one single voltage. So what will be the effective voltage here? Uh, Roshan, you are saying 4 step 1000, but this is milli and this is 1 kilo. So both will get cancelled and this will be 4 angle minus 90. Yes. So what will be the voltage? Is it 3 angle 0 plus 4 angle minus 90 or what will it be?
3 angle 0 minus 4 angle 90.
Yes. So can you calculate it? Tell me.
In the exam will be given complex mode will be there, calculator.
I am not sure. I am not sure. You have to ask. If the calculator is not given, it will be very difficult. But I'm not sure. You have to check with the.
Calculator will be usually given, but I don't know whether we'll be able to do complex number calculations in there.
Okay. If complex numbers are not there, then you have to convert it into rectangular form and then do it
Yeah.
into rectangular form and do. Okay, gate type calculator. So Roshan is saying gate type calculator, but I'm not sure what calculator is given in gate. I have no gate type, so I'm not sure. Okay, so what will be the expression for this? Three angle 0 minus 4 angle minus 90, which is what you have told, but I need the R angle theta form of this.
5
5
angle 53.13.
angle 53.13.
13.
I hope it is correct. Others, please check and let me know. So now they have asked again V naught phasor, which we have to calculate. Again, we'll write the V naught phasor, which is 1 by j omega c by j omega n plus r plus 1 by j omega c into 5 angle 53.13 degrees. Or maybe I will use a different color for this. So this is the voltage. So if I simplify this, again here omega is 10 to the power 6. So V naught phasor is 1 by 1 minus omega square LC plus j omega RC into 5 angle 53.13 degrees. Okay. So now what is the value of omega square LC and what is the value of j omega RC? Can you calculate and tell me quickly?
0.999, 1 minus omega square LC is 0.1.
1 minus omega square LC is. So what is 1 minus omega square LC? How much are you getting?
Is it 0.999?
0.999 again. Okay. And j omega RC? Omega is 10 to the power 6. R is 1 kilo. 1 kilo.
1.
So J 5 angle 53.13 degrees. So now can you calculate and tell me what is the V naught phasor that we will be getting?
Point 55.
0.55. I think that is wrong because here we have 5 by square root of root 2 closely. So we just check 5 angle 53.13 by 0.999 plus there.
Let me check. 2.53 angle 8.10.
3.53
Angle 8.10.
angle 8.1. 3.53 angle 8.10 degrees. So now what will be B naught of T?
3.55 into cos omega t plus 8.10.
3.53 cos into the cos. Okay, let us go and check our answer is matching or not. So it is 3.53, which is matching, and 5 we are getting 8 point something, and it is also matching. How much we were getting? 8.10. So it is in the range. So is this question clear for everyone? I think only 2 people are there. Saunak, is this clear? How we are solving this problem? Let us solve.
Sir,
Yeah, clear. Okay.
sir, please once time tell how the
Okay.
voltage source is both voltage source is I mean voltage source derive in the first case 4 angle 90 degree. Please again repeat.
Okay. So basically what we have done is VS is 3 angle 0, which is already there. So now this part, whatever we have over here, this we are doing source transformation. So we are converting this current source into voltage source. And what will be the voltage source value? Current source, which is 4 angle minus 90 degrees milliampere into resistance, which is 1 kilo ohm. So now what happens? This milli and kilo get cancelled. So the voltage source value is 4 angle minus 90 degrees volt. But if you see, this is the plus and this is the minus. Here, this is the plus, this is the minus. So we have converted this into voltage source, but it is having the opposite polarity of what is there in 3 angle 0. So if I consider this voltage source, so if I consider this as an entire voltage, say some V input bar or V input phasor, what will be the value? Because this is ground, it will be 3 angle 0 minus 4 angle minus 90 degrees, which is what we have done over here. And we got the value 5 angle 53.13 degrees. Now what we have done, because this entire thing is now represented by a single source, and here we have 3 impedances. Voltage across one of the impedances, impedance of that element by total impedance into the voltage source value. From there we calculated V naught. From there we got V naught of T. So is that clear now?
Okay, sir, clear.
So now let us solve. So here they are asking magnitude as well as phase plot. So in the theory I have not covered the Bode plot, but now we can discuss about it. So now they are basically asking V naught phasor by Vi phasor. So what will be the expression for this? Anyone? What will be the expression? So first of
R
all,
divided by
yeah, R divided by,
R plus j omega L plus 1 by j omega C.
there is no capacitor here.
Okay, R plus j omega L.
Yes. So omega is unknown because we are supposed to plot with respect to omega. So it is 1000 plus j omega into 10 to the power minus 3. So multiply by 10 to the power minus 3 on numerator and denominator. You will be getting something like this, 0.1 by 1 plus j omega into 10 to the power minus 6. So whenever they say magnitude plot, as I have not covered, I'm explaining now. Magnitude plot. Magnitude, we will calculate 20 log of V naught by VI with respect to omega. Phase is phase. So now we will be making few assumptions here. So first part is when j omega 10 to the power minus 6 is much less than 1. Then what will be the magnitude? And if j omega 10 to the power minus 6 is much greater than 1, then what will be the magnitude? Okay. So first case. Case 1. What we have considered? 1 is much greater than omega into 10 to the power minus 6. Or I could say 10 to the power 6 is much greater than omega. So basically omega is much lesser than 10 to the power 6. So now what happens? Now I can, if 1 is much higher than this, then 1 plus omega into 10 to the power minus 6, I can approximate it as 1, right? So V naught by VI phasor can be written something like this, 0.1 by 1. Agree?
Yes.
So now what is the magnitude in 20 log and what is the phase? So now we have to calculate 20 log V naught phasor by VI phasor. You tell me the value 20 log 0.1 and phase is simple, it is 0 degrees because it is only real part. So phase is 0 degrees. What will be the magnitude? 20 log 0.1. Can you tell me what is the value of it?
Minus 20.
No, 20. Acha, yeah, you're right. Minus 20. dB. The units are in dB. So it is minus 20 dB. So here units are in dB. The second case will be when this one is much smaller than omega 10 to the power minus 6. So one is much smaller than omega into 10 to the power minus 6, which means omega is much greater than 10 to the power 6. So now what happens? One we'll have to neglect and this will be 0.1 by j omega 10 to the power minus 6. Okay. So what is V naught bar by VI bar? Is 0.1 by j omega 10 to the power minus 6. So it will be 10 to the power 5 by j omega, right? So now what will be the magnitude and what will be the phase?
Magnitude is 10 power 5 by omega.
Yes.
20 log 10 power 5 by omega.
Okay, 20 log 10 to the power 5 by omega, right?
Yes.
Or I can write, how can I write? If I write, I can write 100 minus 20 log omega, right? I can write this, right? Agree?
Yeah.
Okay. So now, what is the phase?
Minus 90.
Minus 90. Okay. Okay, so now let us see. So basically we have to draw something like this. And we'll see how we are getting that, whether we are at all getting that or not. But before that, I want to do, because we have done omega less than 10 to the power 6, omega greater than 10 to the power 6. Let us also see what is happening at omega equal to 10 to the power 6. Case 3, I am considering omega equal to 10 to the power 6. So if omega is 10 to the power 6, what happens to my V naught by Vi bar?
0.1 divided by 1 plus root 2.
0.1 divided by 1 plus j omega. Okay. So V naught bar by Vi bar equal to 0.1 divided by 1 plus j omega. So what will be the magnitude and what will be the phase?
J1.
Phase is how much and magnitude
1
is how
plus
much?
J1 is it not? 1 plus j
Sorry,
omega into 10 power
J1,
minus 6.
J1.
We are substituting
Yeah, you are right. Yeah, thanks
omega
for-
is 10 power 6.
1 plus j. So what is the magnitude and what is the phase?
Magnitude is 0.1 by root 2. It is
20 log 0.1 by root 2. You have to do.
yeah 20. Minus 23.
Minus 23, right?
Yes.
And the units are dB. Okay. And phase?
Minus 45 degrees.
Minus 45 degrees. So now let us draw the magnitude and let us draw the phase. So first we'll start with the magnitude. So we have this is the so we have considered first of all omega less than 10 to the power 6, omega greater than 10 to the power 6. So if omega is less than 10 to the power 6, we got minus 20 dB, right? So usually when we consider less than, it means 10 times less than is lesser than. So we have uh, here 10 to the power 5, here 10 to the power 7. So 10 to the power 7, here 10 to the power 5. Basically, if it is 10 times small, then we can say it is smaller and we can make the assumption that it is smaller than 1. So if this is 0.1, then we can assume 1 plus 0.1 is nearly 1. So that is the assumption that we consider for drawing Bode plot. So omega less than 10 to the power 6 means, so omega until 10 to the power 5. So until 10 to the power 5, what is the value of magnitude? Until omega is minus 20 degree. Yes. So let us consider this as minus 20 degree. So from here to here, we have minus 20. And one more thing, this is omega, right? So this is also in logarithmic scale. So this omega is in also in log scale. And this is gain in dB. So now at 10 to the power 7, what is the value of this?
Minus 20 log omega.
Or one thing you can tell me, what is the value of this at omega equal to 10 to the power 6? Say if this is also valid at omega equal to 10 to the power 6, what is the value of this magnitude? At omega equal to 10 to the power 6? Hello. Say substitute omega equal to 10 to the power 6.
Minus 20.
Minus 20. So actually, if we consider the actual value, omega equal to 10 to the power 6, it is minus 23 dB. But this is an approximation and it is saying minus 20 dB. So basically, from our approximation, we are getting something like this. But actually, the value is somewhere here. But it is still okay whether you want to consider the actual value or whether you want to consider the approximated value, because in the given in the question, basically they are asking what is the waveform. So they have not asked explicitly the value. So it is still okay. But let us consider the actual value and let us carry forward with that only. Okay. And because omega is in log scale, this is my x-axis. So it is like y equal to 100 minus x. So this will be a straight line. So this is my minus 20 dB. So what is the value at 10 to the power 7? 100 minus 40, 140. So it is minus 40, right? Agree?
Yes.
So at 10 to the power 7, the value is somewhere here. And it is falling linearly because x-axis is also logarithmic scale. So basically my y is gain. So gain in dB. So it is something like this. Gain in dB, which is equal to y-axis, equal to 100 minus 20 log omega. And log omega is what? Log omega is my x-axis because x-axis is not omega. So basically what you'll be getting y equal to 100 minus 20x. So it is falling at the rate of minus 20. So basically what is happening is it is falling at that rate. Understood? Yeah. So basically, maybe let me draw it in a nicer way. So basically, if you are considering the approximation, it is falling from here with minus 20 dB per second. But actually, the value is something different. And that something different value is here, it is minus 23 dB. So basically, the actual waveform is something like this. Okay. Because we have made an approximation, so there is some minus 3 dB error at that 10 to the power 6. And this is falling with a rate of minus 20 dB per decade. Because the slope is minus 20 and the units are dB and omega is in the log scale. So that's why it is minus 20 dB per decade. So is this clear or do you have any doubts or you want me to explain again?
Clear. It's
Clear.
clear for me. Others.
Okay, others, if you have any doubt, you can ask. I'll explain it again. Okay, let me consider the phase also, then maybe I'll explain it again. So phase is very simple. At omega less than 10 to the power 6, it is 0. For omega greater than 10 to the power 6, it is minus 90. At omega equal to 10 to the power 6, it is minus 45. So let me keep these calculations aside. Okay. So let us draw the phase. So phase is also with respect to omega, which is in log scale. So this is phase. So whatever we have considered, this is 10 to the power 6, and this is 10 to the power 5, and this is 10 to the power 7. So until 10 to the power 5, phase is 0 degrees. And so until 10 to the power 5, phase is 0 degrees. After 10 to the power 7, phase is minus 90 degrees. So basically, this is my 0 degrees. This is my, sorry. This is my 0 degrees, and this is my minus 45 degrees, and this is my minus 90 degrees. So at this point, 10 to the power 6, it is somewhere here. Basically, what is happening is it is falling like this. Something like that. So basically, phase, it is changing from 0 to minus 90 degrees. So let us go back. So we are getting the magnitude something like this. and phase something like this. So if you go and check, magnitude should be something like this and phase is something like this. So correct option is D. Let me go to the question and let me again summarize what is happening in this question. So basically, in this question, they have given one RC network and resistor they have divided it into two. So 900 and 100. So they are asking magnitude and phase plot. Forget about magnitude and phase plot. First, we need to get the expression for V0 by Vi. So V0 by Vi phasor is 100 by total impedance, which is 1000 plus j omega 10 to the power minus 3. I have written it in a different way, which is 0.1 by 1 plus j omega 10 to the power minus 6. So now I have considered three cases where first case is 1 is much higher than j omega 10 to the power minus 6, so that I can approximate the denominator as 1. So 1 is greater than omega 10 to the power minus 6 is omega less than 10 to the power minus 6. So in Bode plot, the approximation that we can consider is if it is 10 times smaller, then it is very small. So omega less than 10 to the power 6 means omega is until 10 to the power 5. So when omega is less than 10 to the power 6, denominator is 1, numerator is 0.1. We got the magnitude as minus 20 dB, phase as 0 degrees. And the case 2 is omega much greater than 10 to the power 6, means omega is greater than or equal to 10 to the power 7. So in this case, we got magnitude linearly decreasing with the log omega, which is our x-axis, and phase is minus 90 degrees constant. Now the border case is omega equal to 10 to the power 6. We got minus 23 dB and minus 45 degrees. If you consider this expression and if you calculate the magnitude at omega equal to 10 to the power 6, you will get minus 20 dB. But actual value is minus 23 dB. So if you do not consider the exact value, it will be two straight lines, something like this. But exact value will be minus 3 dB smaller than that. So this is minus 3 dB. So there will be 3 dB error at this 10 to the power 6 in the Bode plot. So even if you consider the approximation or even if you do not consider it, is still okay because they have given only the plot, right? So they have not asked the value. So it is still okay. But if they have asked the value, then you have to give the minus 23 dB. So until 10 to the power 5, gain is minus 20. After 10 to the power 7, it is falling at minus 20 dB per decade. So if you extrapolate, you will get something like this. But the actual value is minus 3 dB. So it will have smaller value than what is coming using the approximation. Similarly, phase, if you see until 10 to the power 5, it is 0 degrees. After 10 to the power 7, it is minus 90 degrees. At 10 to the power 6, it is minus 45 degrees. So it is falling something like this. Or you can even draw the straight line if you want to do the approximation. But actual value will be something falling like this. So is this question clear or any other doubts you have in this part?
Clear.
Yeah. Okay, others? What about others? Any doubts? So if you have any doubts, please ask. Don't hesitate. So this will be our last problem, problem 5. Okay. So they are asking I1 and Vs is 4 sine 10 to the power 60. So omega is 10 to the power 6. What is Vs phasor?
4 angle minus 90.
4 angle minus 90. Very good. 4 angle minus 90. So how should we proceed with this? How should I proceed with this question? Any idea how should I proceed? How to solve this question?
See, the question is determine IP and phi or BP and phi.
IP and phi. This is wrong.
Okay.
So this is IP. So how should I proceed with this question? Any idea? Any thoughts?
You can find the two current branches and then add it.
Yes, that is one way. Another way is to simplify this. So this
Impedance.
is Z1 and this is Z2. We'll find the overall impedance and then we'll divide voltage by the net impedance. The other way also you can do voltage by current plus voltage by current. Both are the same. So total impedance need to be calculated. Yeah, Roshan. Yeah. So what is Z1? Z1 is R plus 1 by j omega c, which is j into 10 to the power 6 into c is 10 to the power minus 9. So can you tell me what is the value? It will be 1000 minus j into 10 to the power 3. So basically 1000 into 1 minus j.
J.
So now what is Z2? Z2 is 1000 plus j omega L. J omega is 10 to the power 6. L is 1 micro, 10 to the power minus 6. So it is 1000 plus j. So now we have to calculate the overall net impedance, which is Z1, Z2 by Z1 plus Z2, which is 1000 into 1 minus j into 1000 plus j by summation of these two will be 2000 minus triple nine j. So can you calculate and tell me what is the phasor value of this? Calculate the impedance and let me know in the polar form, which is R angle theta.
$632.5.
Okay, 632.5
Angle minus 18.4.
minus 18.4. So now my I phasor is V phasor, which is 4 angle minus 90 degrees by Z. So I phasor is 4 angle minus 90 degrees by 632.5 into angle minus 18.4 degrees. So if it is in milliampere, we'll multiply by 10 to the power 3. So now can you tell me what is the value of I phasor? So it is 4000 by 630. Sorry,
6.32 milliamperes.
6.32 milliampere angle.
$108.4 minus 108.
No, it will be
No.
minus 90 plus 18.
Yeah. Minus 71.
Minus
7,
71.6
6.
degrees milliampere. So now tell me what is the expression for I of t?
6.32 cos omega is 10 power 6. 10 power 60 minus 71.6. 0.32
Milliampere. So let us see whether whatever we are getting is correct or not. So 6.32 is the magnitude, it is matching. And 5 is minus how much we are getting, minus 71.6. So it is also matching. So that's all for today, the problem solving session. So let me just summarize what we have discussed today. So today we have discussed about the steady state response using the equivalent terms. So basically we have converted everything in terms of phasors, and then we have tried to solve the problems using the phasors, which are the equivalent terms. So resistor is R, capacitor is 1 by j omega c, inductor is j omega. So these are the equivalent terms using which we will solve for the voltage phasor as well as current phasor. Once we get the phasor, then we can write the time domain expression using that phasor. And complex numbers can be written in rectangular format or it can be written in polar form. And kindly note, if it is cos theta, cos omega t, it is angle 0. If it is sin omega t, it is angle minus 90 degrees. Then we have seen few doubts that you have asked. After that, we have seen few problems. So for RC network, they are asking V0. So we have converted everything into phasor and then we have calculated V0 phasor. Similarly, in this question, they have RLC and they have asked the voltage. So first we have calculated the phasor, then we have converted it into the time domain expression. Here they have two sources. So we have done source transformation and then we have converted it into two voltage source, which we have then clubbed to get one voltage source. And then again the same. We are finding the V0 phasor and from there we are getting V0 output. In this question, they have asked Bode plot. So first we got V0 by Vi expression. Then we have considered three cases. And then from the three cases, we have drawn the gain plot as well as the phasor plot. Then in the last problem, we have seen there are two impedances. We have calculated the net impedance and then voltage by net impedance is the current. Current phasor we have obtained. Using the current phasor, we have got the time domain expression. So yes, I think Baby Priya has mentioned one query.
Yeah. In that, that is, we have to calculate V1 using the formula L di1 by dt and minus M di2 by dt. Is it that?
Yes.
But when we that current is in sine, and when we differentiate it, we will get in cos. But the answers were given only in sine. That was better.
Yeah. So I think this will be doubt 4. Right? Let me just doubt 4, doubt 5. So this will be doubt 5. So you are correct. So we have to first write the expression because the current is entering the dot here and current is leaving the dot here. You will get one minus sign. So you will get, I think, something like this. V1 equal to 2 Henry into di1 by dt minus 3 Henry into di2 by dt and V2 is equal to 4 Henry into di1 by dt, sorry, di2 by dt minus 3 Henry into di1 by dt. Agree?
Yes, yes.
So now they have given I1 and I2 in terms of sign. So V1 will be in terms of cos. Yeah, you are right. So let us quickly calculate. V1 will be 2 into di1 by dt is 6 into 2 into cos 2t minus 3 into di2 by dt is 5 into 2 into cos 2t. So V1 is 2 into 6 into 2, it is 12 to 24 minus 30 cos 2t. So if we calculate the final value, we will get V1 of equal to minus 6 cos 2t. You are getting this value only, right?
But the answer was given in sine.
Okay, then maybe they have made some mistake. They made it wrong. So you
Right.
just mention it in the forum. Then I forward it to the TS so that they'll consider it add score or they'll remove it. Is it okay?
They have given 6 sine 2t, I think. The answer was given like.
Okay, okay. Maybe they have made some mistake, I think. Or I think they have calculated this as cos. If it is cos, then it will be 6 sin 2t. So I think they made mistake. Okay, it's fine. You just
Okay,
mention in the forums. I will share it with the TS.
Okay.
Okay, then with that, we can end today's session. And tomorrow I will be taking one more 1 hour session, not 2 hours. So it will be from 6 to 7. And I think they have already shared the notification through mail. So tomorrow I will see if you have any doubts or queries, I'll address them, or I can summarize whatever we have discussed from week 1 to week 12. So by summarizing 12 weeks, I think it will take around 1 hour. So if you have any queries, we'll discuss. Else, I'll just summarize so that if you have any doubts in that particular week, when I am summarizing, you can ask. So it will be only 1 hour session, not 2 hours. So kindly keep that in mind. So with that, we can end today's session over here. And I wish you all the best for your week 12 assignment as well as your final exam. So please be prepared. Go through all the weeks. If you have any doubts, you can ask. You can go through the sessions that I have uploaded. Try to solve as many problems as possible. Don't make any mathematical mistake. Be confident and start solving the problems which you know. And once you have attempted all the problems that you are aware of, then you start solving the problems which you are not so confident enough. But I suggest you to go through all the concepts. Don't skip any concept. Each and every mark is important, so don't skip any concept. If you have any doubts, you can always go through this problem solving session video lectures that are available on YouTube. Okay, then with that, I'll end this session here. See you again tomorrow, which will be our final last 1 hour session. And I wish you all the best. Thanks for joining. Good night.
Thank you, sir.
Thank you.